Hi everyone, my name is George Semaganda again. Welcome to my YouTube channel, and today we are continuing with our AgriGeo Sustain project modeling. So this is the project we are working on. It's a multi-modeling for climatic geointelligence in predicting food security. Briefly, this is the introduction onto our project. If you've been following on the recent classes we've had, this is our fifth class, and this is the problem statement over what we are trying to solve, and it's about the challenges on achieving agriculture sustainability, food security, as well as economic development. So, inadequate resource management and climatic variability impact crop yield and livelihoods. So, your spatial data comes in here to provide us with insights on how we can address these issues and foster a resilient agriculture ecosystem. So in our presentation today, we are in fact focusing on the MLops that involves implementing automated pipelines for training, testing, deploying machine learning models, and the practices at large. So by utilizing these MLops, AgriGeo Sustain can optimize the use of geospatial data and advanced technologies to advance crop yield, thereby reducing resource wastage and promoting sustainable farming practices. So, how does it influence the MLOps trends and techniques? If you continue further, we look at automation, the automation bit. So, the automation uses automated model training and deployment techniques in the MLOps and enable the AgriGeo Sustain to quickly adapt to the changing environment conditions such as weather, then thereby helping us to adjust the farming practices accordingly. Then if you look at versioning, model versioning basically it alters, it helps us to alter the performance after monitoring, and this can help us backtrack. If you can track the effectiveness of different machine learning models and then make driven data decisions, thereby maximizing sustainability, as you can see here on our visual. So this is basically our versioning from minor fixes up to when we are working with new features. Then the application of the DevOps, the data ops, and ML types. So if we look at DevOps, what do we have? So DevOps practices can facilitate seamless collaboration between Agile sustain software developers and agricultural experts, ensuring efficient model development and testing and deployment. With data ops, we enable the Agri Sustain to establish reliable data pipelines, ensuring high quality data inputs for machine learning models and enabling efficient data exploration and analysis. Then, if we look at the heavy versus the light MLOps, so in a nutshell, the heavy ML, it's like they involve extensive automations and r- rigorous monitoring throughout the end-to-end machine learning life cycle. So this approach requires a higher resource investment and a more comprehensive infrastructure compared to the light MLOps. Light MLOps focuses on the essential deployment and monitoring processes tailored to the specific project requirements and resource availability of our project, that is AgriGeo Sustain. So it adopts a more streamlined approach, optimizing the use of available resources. So how do we integrate this, the needs, and then the maturity of the models? So if we look at that, we can look at the hierarchy of the needs, we can look at the MLOps, then robust ML models, then we can look at the high quality geospatial data. So you see this is arranged in a hierarchy model, in a hierarchy technique. So if we continue, we look at the maturity model. So how does our models in production versus the machine learning operation maturity? So if you look at the initial, where we're starting from, then repeatable, then reliability, and then scalability. So this is our operating versus our operating model. So the maturity models basically, it shows us how we are moving from our initial stages until when the project is out there. We have deployed, and now we are into the testing and the use case where people give us feedback and then we reversion our our machine learning model. So if we continue, we look at the handling, data poisoning, data drifts, and then the microservices. So if we break them down, we look at the data positioning. Data poisoning. So what is data poisoning? With our machine learning model, we employ techniques such as data quality checks, then anomaly detection algorithms, and strict data governance policies to help mitigate the risks of data poisoning, thereby ensuring accuracy and reliability of the machine learning model. So if you continue to the data drift, data drift is just a continuous monitoring of the inputs and implementing regular models, retraining. So this can help that model to detect and address data drifts, ensuring that the models remain effective and accurate over time. Then if we look at the microservices, we look at the operationalizing of the microservices. In our model, we can deploy specific machine learning models tailored to specific agriculture tasks and regions, allowing for scalability, adaptability, uh, and all the other practices. So if we look at the continuous integration and delivery, that is CI/CD pipelines, features, stores, then plus Python. Python is our language we are using for this modeling. So if we look at the CI/CD practices, we can automate the testing and deployment of the updated machine learning model in the AgriGeo for our project, and using Python-based projects, thereby ensuring faster and more reliable updates to their agriculture systems. If we continue with the features in store, some of the features we have. So feature stores can serve as repositories for commonly used data features in our project, enabling efficient sharing and reuse across different machine learning models and applications. So where does Python come in? So then our Python project files like requirements.txt, setup.py, then will provide a standardized way to manage dependencies, track project versions, that is the versioning bit where it comes in, and then facilitate collaboration among developers working on this project. So for the collaborations, I think we can consider either GitLab or GitHub, and then plus other softwares that we are going to use. So basically that is what we have. And if you look at the team, we are a team of 3 members. With my teammates, I am George Semaganda, then Eddie Kabogoza, and Ronnie Atwairi. And yes, this is the faces behind the project. And thank you so much. If you have any question, you feel free to post it, and we shall be available to respond. As I conclude, kindly subscribe to our YouTube channels and wait for the next class. Thank you.